I don't know if you can hear her, but there's a cat right here. Let me wind this down here. Hi, everybody. Welcome to the last stream. Well, the last stream before the final review, I guess. Today, I am going to wonder what this is, actually. Oh, I know what this is. This is this thing that I have on the screen here, so we'll deal with that in a second. The point of today is to, I guess, listen to this cat. Maya. Maya. Hi. She says hi. But also to go over any questions you might have for exam number 2. Now, if you don't have any questions, then this is going to be a real short stream. So, type those into the chat. Otherwise, I'm going to get started with a short discussion on lab worksheet number 5. And there's really not much to discuss here because lab worksheet number 5 is simply just another one of those, hey, here's a bunch of videos. Please watch them and then answer questions. So the topic is about solubility. And we discussed solubility in chapter, I believe it was chapter 8. A little bit, yeah. So we talked about like what things will mix with what things. And we talked about how like polar versus nonpolar, those don't mix, but polar versus polar will mix, and so on and so forth. So you're going to be reading a lot of stuff about various ways to dissolve stuff. And then we're going to go into just a few videos about, so here's a video on temperature. Here's a video on, also on temperature. And we have, let's see here. So the first one is table salt, then we have sugar, and then we have coffee. And you should be able to make a general trend or observation on what is more soluble in what, based on what you see. The next thing we have is ionization. Ionization, remember, is just, hey, does something have a charge on it or not? So we've been talking a lot about ionic compounds and that they dissolve in water or they don't. And what we're going to do is we're going to give you 2 different compounds. So we have benzoic acid, which looks like this. Remember that each of these junctions is a carbon, like we talked about in chapter 8 and 9. And then we have sodium benzoate, which is a little bit different. Instead of having an OH up here, it has this O- and an Na+. One of those is going to dissolve better in water than the other. And your job is to watch the video and determine which one is more soluble and why. Then we have the same thing down here with uric acid. This is what your body excretes in urine. We have uric acid and then sodium urate, and you should be able to see a difference between those two and then make a generalization, just like before. The next video is solubility based on carbon chains. So we give you a bunch of different chemicals. We have methanol, ethanol, 1-propanol, 1-butanol, 1-hexanol. And you can see that as we go through the list here, we get more and more and more and more carbons on here. And those carbons have an impact on the ability of the stuff to dissolve. Some of these will dissolve and some of these will not, and they'll make a separate layer if they don't. And your job is to watch that video and tell me what the correlation is between how long the chain of carbons is and its solubility. Is it more soluble when you add carbons in there? Is it less soluble? Does it not seem to matter? Tell me what you think when you watch the video. And then finally, I believe we actually watched the iodine video in class here. I just linked that video again, and you can see where iodine dissolves and tell me some observations on that. And then I just have general questions at the end. So here I give you structures of different molecules, and I say, more soluble in water or hexane? You got to tell me which one, and you got to tell me why. And if you're saying the same thing over and over and over for each question, and it's just like dissolves like, and this is polar, and this one's polar also, or whatever, like, that's totally cool. So don't feel bad. Don't feel like you have to say something unique every time, because these aren't meant to be unique. This is a concept check, right? And if you're applying the same concept to 4 questions, you're going to have the same rationale. And then down here, same thing. If I mix these 2 things together, Like water and then formic acid, will I make one layer or two? Will they dissolve in each other or not? Hexane and benzene, one layer or two. Water and toluene, and so on and so forth. You should be able to tell that based on the picture. For 25, I do give you a hint that I want you to go back and look at number 17. And there's the hint right there. Right there for number 25. So make sure that you see that hint so that you answer this correctly. Because a lot of people get this question wrong. Because they aren't aware that dichloromethane is essentially nonpolar, despite having 2 chlorines on it. Like, 1 chlorine makes it very polar, but adding a second one actually cancels out most of the polarity, believe it or not. That's it. That's really all I have to say about that lab. And there aren't any questions in the chat. So if you have any questions, last call, type them in. Otherwise, it's been a nice 10 minutes. And we'll reconvene again before the final exam, I guess, on Monday. So I'm going to put the music back up here because everybody loves the Wii Shop music, right? And I'll just let it collect... I'll collect questions for 5 minutes, and if there's nothing, we'll call it a day. So see you in a bit. All right, I'm back. I just had to post the I had to open lab worksheet number 5 there so that people could actually turn it in later. And so we do have a question. So let's see here. So from chapter 7, we got a piston that has a gas that is at 10.2 degrees Celsius. Oops, I need my pen here. Pressure 1.14 atm. The volume of the gas is 1.15 liters. What is the temperature of the gas in Celsius if the pressure is recorded to be 4.45 atmospheres after compression to 0.620 liters? So this is a before and after type problem. So we have a pressure, a volume, and a temperature. So initially we have 10.2 degrees Celsius. And we need to turn that into Kelvin because remember that we have to use Kelvin for these or else it doesn't work. Pressure is 1.14 atm. And the volume is 1.15 liters. And I want to figure out what the temperature of the gas is in Celsius, so we're going to have to figure out this. And then the pressure compresses to 4.45 and volume 0.620. All right, so here's our formula for the combined gas law. Remember that you want to use this if you have before-after situations. And we're going to solve for T2 because that's what we've got here. So there we go. So I'm going to multiply both sides by T2 so that I get rid of it from the bottom. And that makes my expression look like this. Now I got to isolate T2 now that it's on the top. Remember, you can't isolate it on the bottom. You'll get the inverse of the answer you want. So I'm going to divide by P1V1 and multiply by T1 so that this cancels and then these cancel. And then we'll do the same thing over here. And so now I just have T2 by itself, and that's going to equal P2V2 T1 over P1V1. And then now we just got to fill in the numbers. So P2, that was 4.45. V2 is 0.620 liters. T1 we got to do in Celsius. So the conversion from Kelvin to Celsius is 10.2 is our Celsius. And then we add 273.15. And then we only get to keep to the 10th place because that's what this is. So I will write down 283.4 Kelvin. We'll write that up here. And then divide by P1, which was 1.14 atmospheres, and V1, which is 1.15 liters. Cancel out the units that can be canceled. And that will give us T2 here. Why don't we multiply the whole left side by T2? We did, didn't we? So this is all already a thing, so I'm just multiplying it and sticking it in the equation. And so here it is right here. Oops, my pen got stuck. What do I get when I do this calculation? Let's type this all in the calculator here. So 4.45, 0.620. I had divided by, didn't I? I did. Oops. Let me try that again. Times 0.620. 283.4 divided by parentheses 1.14 times 1.15. I get 596.4 Kelvin. I only get 3 sig figs, so This would be the answer that I would put in, and then I have to turn that back into Celsius, because that's what the problem wants us to do. So we'll subtract... Oops, hold on, I gotta click on the calculator again. We'll subtract 273.15 from that. So the answer that we should get would be 323 Celsius. So when you compress a gas down to a very tiny volume, the temperature tends to go way, way, way up. All right, there you go. If you have other questions, let me know. I think the most important part of this is remembering that you can't do these in Celsius. So when you do this problem, you have to use Kelvin, because if you input a temperature in Kelvin or in Celsius, and you happen to use a temperature like 0 Celsius, you would basically destroy the equation, right? Or you just get 0, regardless of what all the other things were. So we have to use absolute temperature for gas laws. So don't forget that Kelvin exists. I know it's not very pragmatic. It's not very practical to use it outside of like the laboratory. Like, you're not going to go to somebody and be like, "Oh, it's so cold outside. It's only 280 Kelvin." Like, no, nobody says that, right? Nobody gives a shit about Kelvin outside of the sciences. But since we're studying how gas laws work, we do need to know that what Kelvin is. Otherwise, we can't even use the formulas. All right, I'll put the music back on for like 3 more minutes, and then we will see where we're at. So let me go find that. Where is the music? There it is. There we go. Let's see here. What is the molarity of a solution? Oops, I gotta turn the music off for me. What is the molarity of a solution when 14.5 milliliters of 2.69 molar sodium hydroxide are diluted to a final volume of 200 milliliters? Okay, so I forgot that this class doesn't use ones and twos. Hold on. In fact, I forget what our formula is for this class because I just taught this to a different class and they use it's the same formula, but they use different letters, and so I want to make sure I get the same letters so that I'm not confusing y'all here. That's not what I wanted to happen. So, do we use C's and S's here, or this is the wrong notes? Is it C's and V's or M's and V's? I forget. Yeah, we use C's and V's. Okay. So, just so you're not like, where the hell did M come from? What is M? Different textbooks have different formulas, so okay. So we got concentration of stock solution, volume of stock solution, dilute concentration, dilute volume. All right, so I want... So the final volume will be 200 milliliters. And I'm going to dilute 14.5 milliliters of stock solution. And the stock solution is 2.69 moles per liter. So I'm going to solve for this one. So I'm going to divide both sides by the dilute volume. So those go away. And that will be the dilute concentration. And so we just run the numbers now. So there's my molarity. My stock volume was 14.5 milliliters. Remember, you can use any volume unit you want as long as they match here. Because then they'll cancel out. And then my answer will just be whatever unit I have here, so that's molarity. And, oh, my calculator got buried. Hold on. 2.69 times 14.5 over 200. And that's what I get. So just making you solve for a different variable. I think we solved for 2 of the 4 variables before. I don't remember if this is one of them. But exactly the same process. It's just, can you read the problem and fill in the chart? Any questions, let me know. I don't want to just have dead air going, so I'll put the music back up again. But we'll do another short break, or not really a break, but another just short interval to collect more questions. And if there aren't any, let me know. So. All right, well, if there are no more questions, we'll head back over here and we'll get rid of this. There we go. So just a reminder, exam number 2 is on Friday. If you want your exam moved, you have to do so by the end of today. Wednesday the 9th is today. So get that email to me as soon as you can. Once it's Thursday, you have to take the exam on the day that you're supposed to. So let me know. What else do we have? Yeah, quiz number 9 is due tonight. Well, it was due yesterday. It closes tonight. Make sure that you get that in. And then lab worksheet number 5 will be due next Tuesday. That closes on Wednesday. There will be an announcement sent out for that. Yeah, that's all I got. Thanks for participating, and best of luck on exam 2, and we'll see you next week for the final review. Take care.